Hi everyone, thank you so much for coming to this lesson. So today we're going to be discussing the law of indices, and we're going to be going through the different laws and going through some worked examples to show you how to apply these different rules, and also some exam questions to see if you've understood what we've been discussing. So there's going to be timestamps, so feel free to skip any parts that you don't that you want to, or skip to any parts that you want to be covered, or like pause or go back. Yeah, feel free to do what you want with those timestamps. So the learning objective of this lesson is to be able to understand and be able to use the law of indices for all rational exponents. So to take you through this, first of all, you need to understand what an index is. So let's say you have x to the power of 2. So the index is just a little number, the little 2, that you see on top of the x. So that's just saying how many times you need to multiply x by itself. So if it's x to the power of 2, it just means you need to multiply x by itself twice. So you get x times x. And indices is just the plural of index. So be able to use the law of indices is just different rules that we have in order to make your lives easier when solving different equations, and they're like listed above, like those 6, and I'll take you through all of them individually. And rational exponents are like, well, if you think of a rational number, it's just like a fraction. You can have like x to the power of a half, or x to the power of 3/2. So that's just saying that we're going to be experiencing like a whole range of different like index numbers with these like different rational numbers that could be the powers. So to take you through the laws, so let's start with the first one, is x to the power of a times x to the power of b, and that's equal to x to the power of a plus b. So what it's saying is, if you have an index number which has the same base, so x is the base, so they're both the same, and x to the power of a, x to the power of b, they both have b. So if you're multiplying two different index numbers which have different powers, all you do is you just add the powers. So we're just adding a plus b. So let's say, for example, you have 2 to the power of 2 times 2 to the power of 3. What you would do is you would just add the two numbers together. So you would just do 2 to the power of 2 plus 2 to the power of 3, which is just 2 to the power of 5. So to take you through how this comes about, you can break up the two terms of that equation. So if you have 2 to the power of 2, that's just the same as if we had before. Remember that an index is just saying how many times you need to multiply that number. So 2 to the power of 2, you multiply 2 by itself twice, so you just be 2 times 2. And then 2 to the power of 3, that's just 2 times 2 times 2, and that's multiplied together. So as you see, you have 5 2's, so that is the same as 2 to the power of 5, as 2 is multiplied by itself 5 times. So as you can see, that's what you get over there. So it's just that's just where that law comes from. So the second rule we have is we have x to the power of a divided by x to the power of b, and that's equal to x to the power of a minus b. So this is saying that, that's saying that if you have two different index numbers that you're dividing by each other, and they have different powers, or they could have the same powers, so a and b could be equal, all you do is you just subtract the two. You just subtract a and b. So for example, let's say you have 2 to the power of 6 divided by 2 to the power of 3. That's just this equal to 2 to the power of 6 minus 3, which is just 2 to the power of 3. So to see where this comes from, you can write each one out individually. So you could write 2 to the power of 6 is just 2 times 2 times 6 times, divided by 2 times 2 times 2. So then, as you have common numbers in both the numerator and denominator, you can just cancel out the common term. So 3, like 2 times 2 times 2 is just the common term. So you just get 2 to the power of 3. So yeah, that's just the same as what we got before. So that's just showing you how that, like why that rule works. So the third rule we have is we have x to the power of 0 is just equal to 1. So this is just saying any number raised to the power of 0 is just equal to 1. So we can have 2 to the power of 0, that's equal to 1. That can be same for any number, so 3 to the power of 0, 5 to the power of 0, they would all equal 1. So to understand how this works, so let's say you had let's say you had 2 to the power of 3 divided by 2 to the power of 3. So using the rule that we just learned, like the previous rule, like rule number 2, we know that if you're dividing two index numbers which has the same base, different or same powers, all you do is subtract them. So that's equal to 2 to the 3 minus 3, which is just 2 to the 0. And then you also know that if you're dividing two numbers which are the same, so 2 divided by 2, 2 to the power of 3 divided by 2 to the power of 3, like they're both the same numbers, 2 to the power of 3, that's just equal to 1. So 2 to the power of 3 over 2 to the power of 3 is just equal to 1. So then you know 2 to the power of 3 over 2 to the power of 3 is equal to 1, which is also equal to 2 to the power of 0. So that's where that rule comes from. So x to the power of 0 is always equal to 1. So the fourth law that we had, we can just we can just go over here. And the fourth rule we have is x to the power of a to the power of b, that is equal to x to the a b. So this is just saying if you have x to the power of something and then you raise that whole term to the power of another number, that's just equal to x to the power of the two powers times together. So for example, if you had 2 to the power of 3 all raised to 2, that's just equal to 2 to the power of 3 times 2, which is just 2 to the power of 6. So how do you see that? So if you take the term in the bracket first, that is just 2 times 2 times 2. And then if you raise this by 2, this means that you need to multiply this term by itself. So you would just get this like twice. You get 2 times 2 times 2, and then times 2 times 2 times 2, which is just equal to 2 to the power of 6. So that's just showing you how that rule works. Again, so the fifth rule we have is we have x to the power of minus a, that's just equal to 1 over x to the power of a. So if you have a negative power, you just do 1 over x to that power. So like for example, you have 2 to the power of minus 3. That's just equal to 1 over 2 to the power of 3, which is just 1 over 8. So to see how that works, let's say you had x to the power of 3 divided by x to the power of 5. Using the law number 2 that we had, that's just the same as x to the power of 3 minus 5, which is just x to the power of minus 2. And then if you write this out, you would have x times x times x over x times x times x 5 times, and then you just cross out the common multiples and you would just get 1 over x squared. So that's just showing that these two are equal. 1 over x is the same as x to the power of minus 2. So yeah, that's just showing you that if you have any number that's raised to minus another number, that's just 1 over the number raised to that power. So rule number 6 that we have is we have x to the power of m over n is equal to the nth root of x, all to the power of n. So, so if we have an example, so let's say we have 2 to the power of 3 over 2, that would just be equal to the square root of 2 all to the power of 3. So to break this down and to show you how this comes about, so if you split up 2 to the power of 3 over 2, you could have 2 to the power of a half all over 3. And you can see that is like, if you using the rule we had before with like x to the power of a or to the power of b is equal to x to the a times b. So if you just multiply a half times 3, you would get 3 over 2. So that's that rule applied in this context. So 2 to the power of half, that is just equal to the square root of 2. So you can see that is if you square that, if you do root 2 squared, you would just get 2. And if you also do 2 to the half squared and you multiply a half times 2, you would just get 2. So that's why they're equal. So that's how you get that rule, that if you have x to the m over n, that's just equal to the nth root of x over m. So you could even use that rule with 2 to the half. You would just see that m is equal to 1 and n is equal to 2. So then it's just so it would just be like 2 root 2 to the power of 1. So that's just the square root of 2. So that's the last rule. So these 6 are the different laws that these are the different laws of indices that you have, and I would recommend you just understand how they work, where they come from, understand how like the different examples we've gone through, but just memorize these, as these would be the foundations in a lot of harder questions. So if you understand and learn like these different laws, that you'd be able to do like any other questions really easily.
So moving on to some example questions on indices. If we start with this first one, 8 to the power of 2x plus 3, you need to express that in the form of 2y, stating y in terms of x. So feel free to pause the video here if you want to try give it a go yourself using the laws we just covered, and then you can come back for the solution. So if you don't remember algebraic like equations, just go back to that video, but you should be okay. So what you have to do is, because it's saying 8 to the power of 2x 3, and we want to express it in the form 2 to the power of y, remember when we're dealing with indices, we always have to have the same base for both. So because this is 8 and this is 2, we need to try and turn this 8 into a 2. So you need to think how can you express 8 in terms of something with a 2. So you could also say that 8 is equal to 2 to the power of 3. So you can just change this 8 to 2 to the power of 3. So then you would get 8 to the power of 2x plus 3 is equal to 2 to the power of 3. And then because 8, the whole of 8 is to the power of 2x plus 3, this will also be to the power of 2x plus 3. And you want that in the form of 2 to the power of y. So now we've done that. We've got the same base. Now we just want to deal with what power this would be. How to write this 3 and 2x 3. You just want to equate that with y. So then remember, when we're dealing with indices, we have this rule here. If x to the power of a and then all times b, you just do x, you just multiply it together. This would just be the same as 2x plus 3, and you want that to be equal to y, because you just want to find the same power for both. And then you can just multiply that out, so you'll get 6x plus 9 is equal to y, and we want to state y in terms of x. So that would just be your answer. So moving on to the second question, feel free to pause the video again and try it for yourself. So we want to find the value of 8 to the power of 5 over 3. So to do that, we can just use this rule here. So we'd have 8 to the power of 5 over 3, that's equal to 3 to the power of 3 root 8, 4 to the power of 5. So the third root of 8 is just 2, so 2 to the power of 5, that's just equal to 32. So that's the answer to part A. And in part B, we want to simplify 2x to the half all over 3 over 4x squared. So we just want to multiply this bracket out. So we first get 2 to the power of 3, so that's just 8. Then we have 8 to the half, that to the power of 3. So that's using this rule again, so you just multiply it together. So that would just be 8 x to the power of 3 over 2 all over 4x squared. So now you have 8x to the power of 3 over 2 and 4x to the power of 2. So you can just divide it and cancel out the common denominator, the common multiples, so that's just 4. So you'd have 2x to the power of 3 over 2 all over x squared. And then just using this division rule, you can just subtract the 2 powers. So you'd have 3 over 2 minus 2, and that is just minus a half. So you would just have 2 over x to the power of half, and that's just the answer to this second question.
I hope this lesson was really useful and that you now understand the law of indices. So yeah, I would suggest you now just go through this lesson, make sure you understand this lesson, try some practice questions, see how you get along. And yeah, so thank you so much for listening, and I hope you learned a lot. Thank you.